Okay, so we will start with the question or the topic, which is a control memory. And overall, we need to discuss this stuff, which is related to the how control memory actually works. What are the just a second. Sorry, yeah, sorry for that. Yeah. So, what are the different kind of the working diagram, or we can say flow diagram for controlling the stuff in a control memory? So that we need to discuss over here. Okay. So it will be start with the basic of that. Whatever the arithmetic logic unit, flags, and control buffers are there. Okay. Depend upon their flag and their control buffer register, the one by one that instruction is going to be executed, or one by one that decision is going to be take place. Okay, so it's like that. Depending on ALU flags and control buffers, get the next instruction. So there is a first of the selection address topic we have. Then add 1 to the control address register 1, so it will increment by 1. Jump to the new routine based on the jump micro instruction. Load address field of control buffer register into control address register. Jump to the machine instruction code, or we can say load control address register based upon the opcode in instruction register. So what are this overall stuff is related to us? Okay, so for that, this is a flow diagram we have. Okay, and that flow diagram is related to selection of the address for the control memory, like which type of the task that actually we are doing with your control memory. Whether you are doing a subroutine address, whether you are asking something a branch address, whether you are doing some micro operation, whether you are mapping the logic with that particular control memory, what you are doing, that actually we need to take care over here. Okay, so how it will be there? There are one multiplexer is there, if you have seen. So this is a multiplexer. Multiplexer having an input. If you can see the multiplexer over here. So there are input is branch address. It is also having an input of subroutine register. Having a control address register also is over there. Mapping logic is also there. Okay, so these are the 4 input we have, like branch address, mapping logic, subroutine address, and control address register. So these are the 4 input lines are there in this multiplexer first. Okay, and the line is going to be selected in the output. Depend upon that, what is a selection line you have given over here. You know that how multiplexer works. Depend upon the selection line you have given, it will give you the chance to make that input into output. Okay, so over here that is going to be decided from this multiplexer select line, and it is getting the stuff from the branch logic, what are the status bits and this stuff. Okay, so what are the things we have? So we can say if there are an instruction code is there, like we can say there are any instruction, big instruction if you have written. Okay, so what is the equivalent mapping logic is there? That mapping logic first enter to your kind of the multiplexer. Okay, let's consider there are some we can say that some of the logic has been mapped. Like I have got the I want to get the information about AND gate, which is a sub part of my instruction code. So what I'm going to do, I will find out that what is a control register address for that AND function, and from that control memory operation, that is going to be accessed through that. Okay, there are another stuff is also there, like whatever the logic function is there which is not having a single line, or which is not having a single stuff. Okay, so for that what they need to do, they need to increase the control address register one by one, increment, and they need to finish that particular stuff. Okay, as well as it is also going to be happen like that whatever the increment you are doing, at the same time also there are another subroutine register is also there. Like you have called some particular operation, inside of that operation there are a basic function is there, but to access that you need to go for another subroutine to execute that stuff. So we are also having a facility that whenever such type of the stuff required, so it can go to subroutine register and it will give the instruction over here 112. That's the another thing we have. as well as whatever the control memory we have, from that control memory, whatever the branch address is there, it might be possible that we need to increase by the 1 bit, and again it will go to the kind of the next multiplexer bit. Overall, you can consider the example like that. Let's take you are having instruction codes are there, and with respect to that, let's take XOR. I'm always giving an example of the XOR. So we can say in XOR you required add, AND, and complement function. Okay. So we can say that respective control memory having those functionality, AND, OR, XOR, everything, AND, OR, and NOT, I can say. So respective of that functionality, you need to go to that particular function. And it is possible also that whatever the functions you are calling, they're also having their subroutine. Okay, so to do that XORing function, you need to go with several branch address, like pehle end kiya, baad mein let's take complement kiya, then you need to go with the ending, then again you need to do the complement, then end, then previous ke saath uska or. So we can say every time you need to call a different functions. So we can say in under the XOR, you are having a several stuff is there which is written in a line by line. So we can say that line by line is going to be go with the simple stuff. One by one branch address is going to be executed and line is going to be that line is going to be accessed. Like pehle end karo, baad mein complement karo, baad mein ye karo. So we can say one by one control memory getting accessed and your function is going to be running. In between them, it is also happening like that with particular function. With that particular function, you are having another subroutine is also going to be there with that control register. Okay, like if I say the example with respect to that particular function, you need to access the another memory location. So at that time, you need to go to some subroutine task in between your regular access. So that also I need to include with this either increment or through this subroutine. Okay, depend upon that whatever the control memory status. Okay, there are a status bit is generated in accumulator, like what is a bit is going to be generated if executing this function, and according to that ones and zeros and branching logic is going to be generated. So it will say that overall you can say that how the selection of the address for the control memory is going to be work. It will be like आप ऐसा सोचिए कि like there are AND is there, XOR AND is there, OR is there, NOT is there. So they're having their different set of functionality which is stored inside your control memory. वो सबका फंक्शनलिटी अलग अलग जगह पे आपकी कंट्रोल मेमोरी में स्टोर है. ठीक है, आप उसको एग्जीक्यूट करने के लिए क्या करना पड़ेगा, आपको वहां वो सब रूटीन पे जाना पड़ेगा, उसको रन करना पड़ेगा, वापस फिर से मेन जगह पे आना पड़ेगा, फिर से दूसरी जगह पे आपको एक्सेस, जैसे आपने पहले एंड किया, बाद में उसको कॉम्प्लीमेंट किया, बाद में उसको और किया. सो वी कैन से यू नीड टू गो टू द डिफरेंट सब रूटीन and at that time different address you need to map. So that's the same stuff is going to happen. That overall logic is XOR, just for example, but every time you need to go with the different set of routines. So that going to be executed by either increment on the same location, or you need to increment it by the subroutine location. Okay, so likewise this stuff is going to be happen, and overall your micro operation is going to be executed. Okay, so we can say block diagram of control memory. There are there are examples of that. You can say the block diagram of the control memory and associated hardware needed for selecting the next micro instruction address. By next instruction kya hoga, we require a control memory for that. The micro instruction in the control memory contains set of bits to initiate the micro operation in computer registers. The other bits will specify the method by which the address is going to obtain, like by using a branching or by using a jumping through the carry, or we can say which type of the we can say method through which those address is going to be obtained, direct, indirect, through input output, several stuff we can say. There are 4 different paths from which the control address receives the address. There are, which are the 4 paths from the where the control address will receive the 4 address. It is going to get with the either through subroutine, through the increment of the same control address register, through the branch address, or through the instruction mapping code. So from any of these 4, control address register will get the input. कि भाई अभी ये सब रूटीन में से आ रहा है या जो प्रीवियस था उसका इंक्रीमेंट करके आ रहा है या फिर ब्रांच एड्रेस इंक्रीमेंट होके आ रहा है. सो दैट्स द देयर आर 4 different way which is going to enter into the control address register. So the increment that incrementer increments the content of control address register by 1 to select the next micro instruction in sequence. Okay, branching is achieved by specify the branch address in one of the field of the micro instruction. So we can say like if you require something like you need to this particular task is a sub part of someone. So to do this access, you need to do the branching, you need to go somewhere else and you need to do that particular function. So that we can say subroutine, you need to call, you need to do the branching condition for that and so on. I can also say some of the stuff like that. I'm always try to relate it with the C program. So if you can take the example of that, you have written some function. Okay, you have written some function just apart from the main, but you are calling them like this is a main function. Inside of the main, there are some calculation function you have done. And whatever the function that you have called outside of the main, over there you have just mentioned some of the other function. Third function also is there. Over there are some printf is there. So what is going to happen? Like actually your main program is running inside the main. Okay, but through that there are some branching is there which is going to some another location. They are also accessing some of the condition of the stadio edge, conio edge, and like that. So we can say there are different branching that either you can access it from this one. From that also they will go to some header file and get the instructions. So such type of the branching that you need to do. But over here, how branching is going to be achieved by specifying the branch address in one of the field of migration. So you need to give the address and where I need to go, where I need to get back, like that. So external address is transferred into the control memory via mapping logic circuit. Okay, whatever the external address is there, it's going to map with the mapping logic circuit, and then it is reached to the control memory, and according to that, it's going to execute this stuff. So the question related to that, like draw the diagram of micro program sequencer for the control memory, and you need to explain it. Under that, what is a micro program sequencer? So micro program control unit, which is a control memory and circuits that select the next address. Okay. So what the control memory and the next address, which is going to controlled by the micro program control unit. So the address selection part is called as a microprogram sequencer. First multiplexer selects an address from one of 4 the source and route it to the control address register. So it is a meaning of that. Let me just go to that one. It will be like this one. So from the all the 4 input, it will just select any one of the path. Like it is coming from incrementer of the control address register or subroutine, or from the any other control memory location, or from the external map where it is actually coming. So that's going to be selected. And second multiplexer test the value of the selected status bit, and result of the test is applied to an input logic circuit. Meaning of that, whatever the second multiplexer is applied. This is a second multiplexer, you can say apply. From that second this is a second multiplexer apply. What it will do, it will check. Depend upon the different CPU, and we can say different from the different, we can say carry, okay, zero, sign. Depend upon that, it will give the logic to that T over here. Okay, and according to the test, it will select. It will give the select sign over here that out of this all this stuff. Out of this all this stuff, have you seen this is a AD, this is a BR, this is a CD, there is a mic groups. So depend upon that which logic is fitted to go with the next control address register, which is given from this input logic, and that is going to be controlled by the MUX over here. So we will see the next line, so we will just understand that easily. So CD is a condition field of the micro instruction, selects one of the status bit in second multiplexer. The bit selected equal to 1, the test variable is equal to 1, otherwise it becomes 0. T value together with the 2 bit from the BR field goes to the input logic. Input logic in particularly sequencer will be determined the type of operation that are available in the unit. Okay, so what is the meaning of that? If you can just get the idea. So over here we can say CD, which is a control, or we can say which is a conditions we have, as well as there are, we can say there are a BR, so that we can say it's related to the branch, we can say register. According to that branch register, we can say condition, we can say micro, or kind of the microbes. What is actually going to happen over here? So you can say the CD is going to be over here, BR is going to over here in directly input logic, AD is directly going to the mux. Okay, so what are the thing actually going to be happen to select that which particular input is going to allowed over here in a first mux? यहाँ पे first mux में से कौन सा input output में enter होगा? For that it need to check that whether it is either subroutine, or it's an increment of the previous register, or it is from the external. The main crucial point over here, which is related to the 2 point, like we can say external map. So directly it will just, if you make it 1 1 over here, it means input log that 1 1 and T, which will make overall this S1 and S0 1 1. Then the external map is going to be generated. Now, when this is going to be happen, when this test is also going to give a such type of the input, so it will allow the external logic to enter over there. Okay, and that can be controlled by from this branch address or from this condition. Okay, so you can say like that. You can just consider this stuff कि like आप ऐसा सोचिए कि अगर आपका कंट्रोल मेमोरी में आपका कंडीशन और ब्रांच एड्रेस दोनों आप ऑन कर रहे हो, सो अकॉर्डिंग टू दैट इट विल गेट द आइडिया दैट नाउ इट इज अ टाइम टू गिव द एंट्री टू द एक्सटर्नल स्टफ. तो आप ऐसा सोचिए कि एक पूरा एक मेमोरी एक्सेस हो रहा था, लेकिन वो एक्सटर्नल मेमोरी में, लाइक आई कैन से इन अ कंट्रोल मेमोरी, आपका एक एक्सओर गेट का कोई एक फंक्शन कॉल किया. सो वी कैन से फ्रॉम द overall address in the control memory, initially it will started with the logic function of, let's take XOR. So I can say yes, there are something related to XOR we have. Yes, we have something related to XOR. Now to do the XOR, so I have first taken the condition of XOR, so that I have taken the data from the external mnemonics कि भाई मुझे ये चीज करनी है. Then after you go with the internal stuff कि भाई चलिए XOR करने के लिए अभी क्या क्या चीज करना पड़ेगा. So you can say to do the XOR, you are having the entire routine is there. That routine contain AND, routine contain OR, routine contain NOT gate, then adding. There are several stuff is there, and you need to take some load, clear. You need to just store it, temporary place. Several stuff you need to do. So you can say there are your internal control address is going to be there, which is running behind of that, and it will make this oral XOR possible. Okay. तो अभी वो कंट्रोल एड्रेस रजिस्टर 1 by 1 एग्जीक्यूट होगा कि वो एक्सओर करने के लिए पे ये करिए, ये करिए, ये करिए, ये करिए, लाइक दैट. सो वी कैन से दिस लूप इज गोइंग टू बी रनिंग ऑन कि भाई आफ्टर गेटिंग अ ओवरऑल फंक्शन XOR, whether I am inside of that the particular loop or not, so that is going to be loop is going to be created over here only. Control address register, increment, get the access, do the stuff like this one. Now it is also happened that whatever the inside register you have, whatever the inside memory you have, let's take you need to go to somewhere else, jump instruction you need to do. So whenever you need to jump or whenever you need to call some subroutine, so at that time it is possible that from the main function it is go to subroutine and then again came back to this loop function. So at that time subroutine called, and according to that some data will came and control memory will access that. Okay, so this is overall loop is going to be happen, and once entire stuff is going to over, that we have done this control memory access of this XOR, that is done. So now you again need to go to the next external map address. So likewise the hierarchy you need to keep in mind. Like पहले बड़ा फंक्शन था, उसके अंदर एक लूप चल रहा है, उसके अंदर भी कुछ फंक्शन हो गए जो आप अलग अलग रूटीन से कॉल कर रहे हो. Then you need to execute one by one, and again you need to kind of the come to the main function. So this is overall stuff is going to be happen inside of that micro program sequencer in a control memory. Okay. If we can say what are the truth table is there. So we have several stuff I0, I1, T, and there are several stuff ISZ we have. So this is a overall truth table we have. So BR field will be something 0, 0, 0, 0, 0, 1, 1, 0, 1, 0, and 1, 1 will be there. At that time, if I1, I0, and T will be 0, 0, as well as L, S, all are 0. All BR field, input, marks, load, SBR, all are 0, then it is go with the simply next address. Otherwise, if T1, S01, then it will go with the specific address. If there are something stuff related to 1, 0 in the BR field, it will go to some subroutine. But condition is there where I1, I0 will be something is going to be 1, and your S1, S2 also is set as a 1, so it's subroutine. Otherwise, if there are external address you want to access from that, so which is making that BR field needs to be 1, 1, and I1, I0 also 1, 1, S1, S0, 1, 1, then it will give the external address. So next address, specific address, subroutine address, or external stuff, that is going to be selected from this combination of this all this stuff. Okay, so if you have a question like what is inside of this S1, S0, how S1, S0 is generated, तो अगर हम यहाँ पे देखें कि भाई ये S0, S1 कैसे generate होगा, it is going to be generated by this equation. S1 equal to I1, S0 equal to I1, I0, I1 bar IT. Okay. While L, whatever that L is going to be there, this is a L to give the construct or to give the signal to subroutine. That L is going to be generated by I0, I1 bar and T. So from this table, this is overall stuff which is going to be generated depend upon I1, I0, T and all the things. Okay. So अगर ये box के अंदर क्या होगा? So that is a logic over here. So we can say under this particular stuff, let's take what are the things. Let's take BR equal to 0, 0. Symbol will be jump. So AD, whatever we can say, AD will be there. It's set to the CAR if condition 1. CAR equal to CAR plus 1 if that condition is going to be 0. Okay. So what is the meaning? I can say directly, like if the symbol will be jump, call, return, map, such type of the symbol you can say if it is come in your structure. So for all that stuff, whatever your BR field, like when the BR field is going to be make 0, 0, when you are having a jump symbol. So at the jump symbol, obviously you need to go to the next address. So that's why that control address, if that set is going to be like AD. So what is the AD we have? Okay. So this is a, we can say, this is the AD we have. Yeah. So there is an address, whatever that control, or we can say there are a control bit generating from the memory. If that AD going to be, that AD is set to the control address register, and if the condition 1 that is increment by 1, it means jump, it means you need to go to that a particular location, whatever the address is mentioned by that, you need to go over there and you need to execute stuff. So we can say whenever jump instruction, you need to jump to that location from the control memory. While we can say call, what will be there? If there are a 0, 1, so I can say it will be call. So first, whatever the right now address is there, you need to give to the control address register. Then you need to make subroutine address plus 1. Then if condition going to be 1 is going to be there. But if that control address is simply just increase the 1, if condition 0, it means whether there are a call function, and if you want to go to subroutine, or you need to call this stuff over here as it is. Like today, आज हमने एक multiplication का example दिया. So if there are a jump 0, I can say if there are a jump 0. So whether I need to just stay over here or I need to jump at the specific location, depend upon the AD you have given. Okay. So if related to that BR field going to generate it, you need to access that whether you need to come over here or you need to increase by 1 or you need to increment it somewhere else. Okay. Whenever there is a 1, 0, so it's a subroutine return. So whatever the subroutine is there, you need to get back from that one. Okay. And whenever there is a 1, 1, so it's a map. It means whatever the control address be it, then data register be it, then rest of the bit it's going to set to something else, something like this one. So it will go to the executed kind of the instruction page, you can say, or what are the proper name we have given? We have given the name as a, yes, mapping logic. So you are in the condition of mapping logic. Mapping logic will be also like whatever the instruction code given from the external, you are mapping it with the available logic inside of your control memory. Okay, so this is the overall stuff. Like as I have given you the example, like it can be go in that sequence, or it will call to some subroutine. So whenever there are a subroutine, so such type of the BR register going to generate it. If it is coming back from that stuff, so then are 10 or such type of the BR register set. Okay, so depend upon the BR, depend upon the rest of the numbers, your different address subroutine is going to be executed over here. Next we have, which is a draw and explain a computer hardware configuration with the micro program control unit. Okay, so this is the computer hardware configuration, okay, for the micro program control unit, how it's going to be work and what are the things we have. Okay, so in a control unit, there are a control memory, SBR, CAR, as well as it's having arithmetic and logic shift unit, accumulator, MUX, data register, memory, MUX, address register, program counter. It's all the things we have. But for the micro program control, just a second. Okay, yeah. So for the microprogram control unit, what are the computer hardware configuration required? So for that, you can say this is a control unit. So that control unit overall having some control memory, okay, having kind of the SBR register is there, control address register is there, and overall control unit is situated. Okay. As well as there are other functions, or we can say other memory is also situated, like 204/16 memory, which is it's available with through the MUX, and that is connected to data register. Data register give it to arithmetic logic shift unit, accumulator, and again accumulator come over here like that. As well as whatever this we can say this is a memory function, that is a control line will be available at a memory, as well as it is available at the address register, MUX, program counter. Okay. So what is the overall, we can say the meaning of this particular stuff? So whatever the control unit is there, how it will get the, sorry, just a second. How it will get the data, you can say. So this block, I think it's, you can directly relate it with the stuff like there are some arithmetic unit. It is having some data register. It is having some accumulator. So data coming from data register, performed in the arithmetic unit, and give the data on accumulator. And it might be happen that same accumulator need to be again set as a data register and do their stuff with their own. Like we are doing sometimes XOR, or we are doing something stuff related to their own accumulator logic. So at that same time, this loop is going to be considered as that. That accumulator is just give that data to multiplexer into data register, or directly it is go with the arithmetic logic unit self, we can say program, we can say. So that's going to be happen in this one. As well as whatever the data coming inside of the data register might be from the memory. Okay, that some of the data has been stored from the memory, that is going to become over here. As well as which memory location you need to access to do this stuff, that coming from address register. Like this is address register, this is a memory, and that is a 16-bit data you need to do with this, we can say this arithmetic and logical shift unit. Okay, and that address register also give the instruction to program counter. like with that program counter, which type of the number is going to be stored over here. And according to that, what you need to do with that data register, either you need to increment those program counter or you need to fetch the data from memory. You can directly see like that, whatever the functionality will be there, whatever the things that you are doing. Okay, that is come to the accumulator. Why? Because arithmetic and logic shift unit over here. So sometime program counter come over here, increment their self, and then it is again go back to the position of their kind of the memory access block. So कौन सी मेमोरी एक्सेस करनी है, कहां से पता चलेगा, कौन सा आप एड्रेस रजिस्टर दे रहे हो, उसको कहां से इनपुट मिलेगा, what is my previous memory address reference with that, and what is the multiplexer I'm just setting, or what is the different multiplexer I can say program counter that I'm just using over here. तो नेक्स्ट प्रोग्राम काउंटर क्या था, उस हिसाब से यहाँ पे मल्टीप्लेक्सर में मैं अगला प्रोग्राम काउंटर डिसाइड कर सकूंगा. एंड सेम प्रोग्राम काउंटर कैन बी रिफ्लेक्टेड इन डेटा रजिस्टर ऑल्सो. आप ओवरऑल ऐसा इसको सोच सकते हैं कि लाइक whatever this overall block are there, like getting the stuff from memory, getting the stuff from multiplexer, getting the data from data register, performing their arithmetic and logical operation, performing their memory access operation, that overall it's going to be related with the control address register that you are giving in your control unit. So ये सब ब्लॉक है जहां पे आपका मेमोरी, उसका टेम्पररी जो भी आपका प्रोग्राम है वो स्टोर हुआ है, आप उसको परफॉर्म कर रहे हो. From that, overall this memory and their address and all thing is going to be situated. Okay. और यही चीज आपको करनी पड़ेगी, like whatever the micro program control we have, which is required several stuff. What is required? It will require some data register to go inside of your pipeline, perform some experiment in accumulator and get back on the original position. So you require the arithmetic logic unit for that, accumulator for that, data register for that. Some program counter also you need to mention that what is the next sequence. So this all block is going to be related to that. Okay. But over here in the main stuff, you need to, for this particular program or this particular chapter, you need to understood about program count, that micro program control, that different block we have, control address register, control data register, control memory and all this. So these are some of the things, like two memory units we have, main memory, control memory. Main memory for storing the instruction and data, control memory to storing a micro program. SIG register, accumulator, PC, AR, DR, CAR, SBR. Multiplexer to transfer the information among register in the process done to the multiplexer. These are the some of the block that you require to do this particular block diagram. Okay, so this is overall stuff with that. Yes, we require ALU to do the arithmetic logic shift operation from the accumulator data register, and we need to place result into the accumulator so next instruction can access it. So in computer hardware configuration with microprogram control unit, data register can receive from information from that AC and PC, AR can receive from PC and DR, program counter can receive from AR. So these are the paths they have mentioned, like which particular block will get the data from which one. That's the overall stuff is mentioned like this one. So next and kind of the most important stuff that we need to discuss over here, that what are the difference between hardware control and microprogram control architecture, you can say. Hardware control is a fast, it's a slow. Why? Because in hardwire already dedicated circuit is there, you just need to give that instruction, it will start generating a control. While in microprogram you need to go to the several stuff, you need to go with the several routines, and then it's going to be executed. While in terms of costlier, hardware control is costlier, while microprogram control is cheaper. Because why? To hardware control you need to design a dedicated unit, and that's become kind of the more costlier. Okay. Hardware control error will be more, while microprogram it's less implementation in hardware, while microprogram control it is in a software. Flexible, obviously hardware is not flexible, so not flexible to accommodate a new system specification or new instruction redesign is required. While microprogram depend upon the new flexibility. If you want to add some instruction specification, so it's going to be added in your system through the changing in a microprogram. Complex instruction set difficult to handle. Microprogram control easier to handle. ओके सो XOR और ऐसा कोई भी फंक्शन दे दो, उसके नीचे तो बेसिक लॉजिक फंक्शन ही है जो सब रूटीन है, आपको वो सब रूटीन ही कॉल करवाने हैं. So we can say it is going to easy to handle, where in hardware it's overall structure to create for the large number of instruction, it's difficult. Design process complicated, while microprogram ordinary, systematic and simple. While decoding and sequencing complex, while microprogram is easier. Like previous में आपको थोड़ा ये कॉम्प्लेक्स लगा होगा, लेकिन आप ऐसा सोचिए कि आपके पास एक प्रोग्राम है डेडिकेटेड, आपको वो प्रोग्राम एक्सेस करना है, तो आप क्या करोगे? यू जस्ट राइट अ रूटीन, यू जस्ट राइट अ स्क्रिप्ट फॉर दैट कि भाई कोई भी अगर XOR बताए तो ये स्क्रिप्ट रन करनी है, दैट्स इट. बिकॉज ऑलरेडी हार्डवेयर, ऑलरेडी स्टफ इज देयर, यू जस्ट नीड टू run that script and that stuff is going to available automatically. Area hardware control required more, microprogram it's required less. Okay, so for the each and every stuff, like आप hardware control करते हो तो हर एक functionality के लिए, हर एक instruction के लिए you need to create a dedicated hardware for that. But in microprogram, one hardware, one design hardware can use in several instructions simultaneously. Okay, so their overall burden on program, not on hardware. What is the micro instruction format? Okay, so we can say 20-bit micro instruction code that you can represent like this one. So this is going to be happen like this one. It is just F1, F2, F3, which is a micro operation field. CD will be coding a condition for branching. BR will be branch field. Address will be 7 field. So 3339 plus 4, 13 and plus 7. So there is a 20 kind of the bit of the format you have for the entire micro instruction. Okay, like which micro operation field you go, which branching condition you are applying, which branch you are going, which address you are going, all is going to be coming in a one single format. So what are the condition of CD? So if there are a 0, 0, so unconditional branch. If there is a 0, 1, so indirect address. If there is a 1, 0, then it's a sign bit, or we can say that is a sign bit of accumulator. And if there is a 1, 1, so it's a 0 value is generated. While in BR condition, it's a jump, call, return, map that we have discussed previously. So in micro instruction format, you can say 20 bit of the micro instruction are divided into the 4 functions. There are 3 fields, F1, F2, F3 specify the micro operation for the computer. While CD fields select the condition. What is the condition related to accumulator? BR field specify which branch you need to use. AD field contain the branch address. And the field address field is a 7-bit wide, since the control memory has a 128 2⁻⁷ words. Okay, so you can say depend upon the address field, which is a 7 we have over here. So we can say 2⁻⁷. Overall 128 address is going to be related to that. Okay, so that much of the different address that you can target it through this one. Okay, so in general, when I say the micro instruction format, so आप कौन सा micro operation field अभी execute कर रहे हो? Whether you are using a conditioning, whether you are using a branching, whether you are just doing unconditional branch, direct address bits, you are using sign, whether you are using an address field or not, depend upon that, overall micro instruction format is going to be happening. And this is a sum of the micro instruction program, you can say. So F1, you can say symbol and binary code for micro instruction will be, F1 will be having kind of the set of the stuff we have. F1 will be something 0, 0, 0, then 0, 0, 1, 0, 1, 0. So F1, F2, F3 will be 333 byte. So we can say if F1 will be 0, 0, and none, 0, 0, 1, then this instruction, then 0, 1, 0, then this instruction. Like if there are a micro operation F2, it's go with the subtract, or and read or increment, P program counter to data register. F3 will be 0, 0, so it will be like, so you see, by setting the stuff, F1 में आप 0 1 0 कर रहे हो, F2 में आप कुछ और कर रहे हो, F3 में, तो जिस तरह की आप कंडीशन यहाँ पे देते हो, according to that it is doing the clear or XOR. Likewise the combined stuff is going to be work with that. Okay, so this is inside of F1, F2 and F3, 3 bit. There are 8 possibilities are there. Okay, so it is containing some of the arithmetic operation, logical operation, okay, shift operation, there are some transfer operation, okay, memory access operations are there. That's all stuff going to happen. So that's it in a chapter number 4. Starting with the question. Any question to anybody? First of all, tell me. Or let me take the attendance first. Let me take the attendance first. So it is a better for everyone. Yeah, so start with the number 37.
Yes, sir.
Smee?
Yes, sir.
Okay. Say the next number. 2, 3, 4. Say like that.
3 present, sir.
2 present. 3. Then 4, 5, 6.
Yes, sir.
7, 8, 9,
11, sir, 9.
10. Keep
Yes,
your
sir.
11.
10,
7 is present.
7 present. 8. 8 is not there. 11,
Yes, sir. 11 present.
12.
Present, sir.
Next number.
Present, sir. 13.
Next.
14. 15. 16.
18.
20.
21.
22.
23.
25.
27.
26.
26.
Yes, sir.
27.
28. 30. 31. 32.
Yes, 32.
33.
Next.
35.
31,
36.
37.
30, 37.
38.
Okay.
39.
Okay. 501. Manan Parmar 1. No. 2.
502. Present. 502.
Okay.
Present 4. 504.
503 not there. Okay. 505.
Sir, 31 present.
31 present. Okay. 505. 506.
Yes, sir.
507.
Yes, sir.
8.
Present, sir.
509. 510.
Yes, sir.
511.
Sir, 503 માઇક બંધ છે એ પ્રેઝન્ટ છે.
503. Chalo, see the number. Regular 2, 4, 5, 8, 17, 28, 30. Anyone present from this one? Okay. In a new enrollment number 1, 5 and 9. Is it okay, absent? This is the absent number, okay? Okay. Yeah, so come back to the question. Yes, if you have a question, ask me, please. Yes, I'm open for question now. Yes, my friends, any question? If you're not having any question, then better we can go with the writing a summary in the chat box, and then after you can go, okay? Write the summary in the chat box, everyone. And if you have a question arise in your mind, so you have 10 minutes of time to ask. Please do that, everyone. Thank you, Udit Raj. Thank you, Abhishek. Thank you. Have a great day.